Ko. This is Haunani here, and this week we'll be going over Module 2A, Types of Volcanoes and Eruption Styles. I really love this picture here. You can see this is a view from Mauna Kea. You can see the snow at the peak of Mauna Kea, looking towards Mauna Loa as lava is coming down Mauna Loa in the 2020, one of the most recent eruptions that we had here on Hawaii Island. This week, as a part of Module 2, we will go over what is a volcano, as well as the types of volcanoes and eruption styles. Most of the material that we will be covering in Modules 2A and 2B will come from this book here, Volcanoes in the Sea, The Geology of Hawaii. It is a classic written by Gordon A. MacDonald and others. You can find a few chapters of this book related to the modules that we'll be covering on Laulima. However, if you are really intrigued by the material that we cover this week as well as throughout the class, I really encourage you to get a copy of your own, either at the library or you can purchase it easily online. So what is a volcano? Well, in Olelo Hawaii, or the Hawaiian language, a volcano is referred to as Lua Pele, Pele, or Ahi'ai Honua. Lua Pele refers to the house or pit of Pele. Pele is the deity, the volcanic deity that we often refer to when we speak of volcanoes. So when you talk about an eruption or the lava, that can actually be referred to as Pele itself, as a form of Pele. Ahi'ai Honua literally translates as fire that eats the earth or land. A volcano may also be defined as a place where molten rock or magma and or gas from within the earth is at the surface. The term is also used for the hill or mountain built by the rock that is poured or blown out. Oftentimes when we speak of volcanoes, we also talk about craters. So a crater is referred to in Hawaiian as a lua. And craters are these bowl-shaped or funnel-shaped depressions. They are not hills. A volcanic crater usually lies directly above the vent from which the volcanic material is ejected. And these craters can be found at the summit of a volcano, but also often on its flanks. They may occur even in non-volcanic rocks, completely apart from any volcanic mountain. So long as they are formed by volcanic action, they are volcanic craters, no matter what the nature of the surrounding rocks. Here in this image, you will see Halema'uma'u crater here, which is a pit crater located within Kilauea caldera. So this is located at Kilauea, the volcano. If you've ever been to Kilauea, you may have parked here at the visitor center and then driven around to look at the caldera. And again, the craters are found within the caldera. This is where we had the most recent eruption earlier this year. If we take a closer look at the map here, we see that Kilauea, you can find more than 10 other craters on the volcano, and many of them are located here along the East Rift Zone. And just for context, this was Kilauea crater, which we spoke about in the previous slide with the visitor center located here. If we take a closer look at the most recent eruption on Hawaii Island, we see that a summit eruption occurred at Halema'uma'u earlier this summer. This image was taken from June 7th, 2023. And the eruption itself began at about 4:44 a.m. In this image, lava is flowing on the crater floor and there are several active vent sources. The eruption at Kilauea Summit occurred within a closed area of Hawaii Volcanoes National Park, So the primary hazard of concern was high levels of volcanic gas rather than there being a direct impact of the lava itself upon people, houses, or the surrounding places. Here is an image of Lua Poholo, a pit crater located on the northern side of Moku'aweoweo. Moku'aweoweo is Mauna Loa's summit caldera. So again, here is a pit crater located within a caldera on Mauna Loa. One of the big questions that we have when we have eruptions here in Hawaii or across the world is, will the eruption be explosive or not? Some volcanoes are wildly explosive, while others are gentle in nature. The fluidity or viscosity of the lava and its gas content determine if an eruption will be explosive or not. Viscosity refers to the resistance of a material to change shape or flow, whereas low viscosity or fluid lava allows moderate amounts of gas to bubble out with little more than minor splattering, resulting in gentle or non-explosive eruptions like the top image. So if something is fluid, if a volcano has fluid lava, low viscosity, then it's typically non-explosive. However, in very viscous lava, it's difficult for gas to work its way upward and break through the surface of the liquid. Gas then accumulates until the pressure is sufficient to allow it to burst free. With high enough gas pressure, a large enough amount of gas, and viscous enough lava, a major explosion or series of explosions may result, similar to what is shown here in the bottom image. We're going to go over in more detail explosive versus non-explosive eruptions later as we talk about the different types of volcanoes. So there are three main types of volcanoes that we will cover in this lecture. The first on the left-hand side are cinder cones. In the middle, you will see an example of a composite volcano, also known as stratovolcanoes. And then on the right, you will see a picture of shield volcanoes. So it's going to be important in your quiz that you take later that you're able to distinguish between these three different types. Provide some examples of each, and also know which of these volcanoes are explosive and which are not. So first we're going to talk about cinder cones. Cinder cones are the simplest type of volcano. They are made of small pieces of solid lava called cinder, hence their name, that are erupted from a vent. The ground shakes as magma rises from within the earth. Then a powerful blast throws molten rocks, ash, and gas into the air. The rocks cool quickly in the air and fall to the earth, breaking into small pieces of bubbly cinder that pile up around the vent. They accumulate as a small cinder cone that can be as high as 1,000 feet above the surrounding ground. If the wind is blowing during the eruption, cinder is carried downhill before it's deposited into an oval shape. Eruptions that form cinder cones also feed lava flows that spread outward from the erupted vent. When you climb a cinder cone, you can usually find a bowl-shaped crater marking the location of the vent. If the eruption of cinder and lava flows happen repeatedly over the same vent, the overlapping layers can form a larger volcano. So here is an image of a cinder cone. Cinder cones are commonly found in association with other volcanoes, and they can be found on the flanks of shield volcanoes and on stratovolcanoes. So this is an example of, or this is an image of Pu'uo'o fountain from Kilauea. Here is an image of a composite volcano. Some of the Earth's grandest mountains are actually composite volcanoes. Sometimes these volcanoes are also referred to as stratovolcanoes. They're usually tall with steep sides and a cone shape. So you get a distinct, when you see something, a volcano shaped like this with steep sides and a cone shape, that is a great indicator that it is in fact a composite volcano. And what gives it this shape is the fact that the lava is viscous, it's sticky, it doesn't flow easily, and it instead builds up around the vent, forming steep sides. You're more likely to produce explosive eruptions due to gas building up in the viscous magma. And rocks are typically composed of andesite. So this tall, steep, even sides are made out of repeated layers of lava flows, including volcanic ash, cinder blocks, and volcanic bombs. Some composite volcanoes rise over 8,000 feet above their surroundings, but they reach much higher elevations when compared to the level of the sea. Here in this image, you will see Mount Fuji in Japan. And so composite volcanoes are explosive. They have steep sides, a cone shape, and they are composed of viscous, sticky lava. I now want you to pause this recording and copy this YouTube link, and here you will see a video of an eruption, an explosive eruption of a composite volcano. This video is of the volcano Mayon in the Philippines. So again, pause your lecture video and take a look at this video here to see what a composite eruption looks like. How do composite volcanoes form? Composite volcanoes form at convergent boundaries. When two plates come together, it is known as a convergent boundary. If you have a continental plate colliding with a continental plate, this typically causes the edges of one or both plates to buckle up into a range of mountain ranges. However, if you have, say, an oceanic plate colliding with a continental plate, then typically what you have is you have the oceanic crust being subducted beneath the continental crust. During this process, you form a linear chain or a series of volcanoes, as shown here, parallel to the collision, as well as a series of earthquakes in response to this collision process. At convergent plate boundaries, oceanic crust, again, is being forced down into the mantle where it begins to melt. Magma then rises up towards the surface through the continental crust, and it solidifies into rock after it is erupted at the surface. This rock makes up the continent itself. Thus, at convergent boundaries, continental crust is created and oceanic crust is destroyed as it is subducted. Here is another example of a composite volcano. This is Mount Rainier in Washington, ascending to nearly 14,400 feet above sea level. Mount Rainier stands as an icon in the Washington landscape. It's an active volcano, and it is one of the most glaciated peaks in the contiguous U.S. It also spans 5 rivers. Here is another volcano. Here is Santa Maria, or I'm going to butcher the name, but Gaxanul in Guatemala. This is a view from the east from the summit of Santa Maria volcano here, and you can see from this view there are a series of composite volcanoes, each labeled with their initials in this image. And you can see in each of these composite volcanoes that they have the shape, the steep shape, steep sides, and the cone-like shape. Here is Colima volcano, again another composite volcano. Colima volcano in Mexico is one of the most active volcanoes in North America and one of the potentially most dangerous ones. It has had more than 30 periods of eruptions since 1585, including several significant eruptions in the late 1990s. Scientific monitoring began about 20 years ago, and the largest eruption for several years occurred in May of 2005. An ash cloud rose to more than 3 kilometers over the volcano, and satellite monitoring indicated that the cloud spread over an area of 110 nautical miles west of the volcano. Pyroclastic flows travel 4 to 5 kilometers from the vent, and lava bombs landed 3 to 4 kilometers away. So again, composite volcanoes have explosive eruptions. Next, we're going to move into the third type of volcano, shield volcanoes. Shield volcanoes are built almost entirely of fluid, low viscosity, runny lava. It spreads far from the source and forms a volcano with gentle slopes. That is because as lava flows out, the fluid lava spreads out in all directions from the summit or along 2 or 3 rift zones or fractures that radiate out from the summit, similar to spokes on a bicycle wheel. As lava flows overlap one another, they construct a broad, gently sloping, dome-shaped volcano. On Earth, some of the most massive volcanoes are shield volcanoes, and we'll get into this more in later slides. Eruptions are typically gentle and are only explosive if water gets into the vent. Again, shield volcanoes are low explosive volcanoes. They may have fountaining that occurs that forms cinder cones, but for the most part they're low explosivity unless the explosions interact with the water table. And rocks themselves are typically composed of basalt. Here is an image of a shield volcano in Hawaii. This is Mauna Kea. You can just barely make out the telescopes on the top of Mauna Kea. Again, take into consideration, whereas composite volcanoes were more steeply shaped, steeply sloped sides, here we have a gently sloping, broad, dome-shaped volcano. Whereas composite volcanoes form at convergent boundaries where one plate is being subducted under the other, shield volcanoes form at hotspots. They form in the middle of plates. Notice in this image that all volcanoes are located either in the middle of the ocean or in a continent. They do not occur near plate boundaries. What is a hotspot? A hotspot is an area of the Earth's mantle from which hot plumes rise up. So here they rise up, forming a volcano in the overlying crust. The Hawaiian Islands and the chain of seamounts that continue their trend for about 6,000 kilometers into the northwest Pacific Ocean are an example of a hotspot track. The island of Hawaii is the youngest. Here is Hawaii Island and the most active volcano in the chain. Active The active location of the hotspot itself is currently located at Kamaehu a Kanaloa, formerly known as Lo'ihi, which is located off of the southeast flank of Hawaii Island. Hawaii Island currently has had active eruptions within the last year at Kilauea as well as Mauna Loa. And then as you move towards the north, towards Maui, Molokai, Oahu, Kauai, Ni'ihau, and eventually into Papahana, Mokuakea, you will see that the age of these islands increases as well as the amount of erosion that they have experienced. So, current hotspot is just off of Hawaii Island. And we see that this is where we have our active volcanoes and our tallest mountains. Hawaiian type eruptions is a term that is used to explain the eruptions and the building of shield volcanoes across the globe. Shield volcano eruptions, again, are gentle and non-explosive. This is due to low gas and high fluidity or low viscosity of the magma. So again, I'm going to ask you to pause your lecture video, copy this link and watch it on YouTube, and view what a Hawaiian type eruption looks like, what it looks like when a shield volcano erupts. Okay, so pause this lecture video now, open a new tab, and watch this video of a Hawaiian type eruption. Again, due to the high fluidity of shield volcanoes, most Hawaiian volcanoes, especially when they're young, are elongate rather than round in map view. So you can see here is Mauna Kea, one of the tallest volcanoes in the world. Here is Mauna Kea, one of the largest volcanoes in the world. And then we have Kilauea, Kohala, and Hualalai. So there's 5 volcanoes in total on Hawaii Island. And as we mentioned before, their shapes are elongate rather than round in map view. And map view, you're just looking from above onto the surface of these volcanoes on Hawaii Island. Here is an image of Mauna Loa. Again, Mauna Loa is one of the largest volcanoes. It's also one of Earth's most active volcanoes. Since 1843, it has erupted 34 times, producing lavas that have covered over 800 kilometers of area. The image here shows Mauna Loa with a little bit of snow on top of it. So during winter months, it's not uncommon to see Mauna Loa and her being snow-capped. Here in this image, you see that the colors here show all of the eruptions of Mauna Loa since 1832. So you can see just the pure extent, how huge this volcano is. This map still needs to be updated to include the 2022 eruption. We're going to wrap up lecture 2A by talking about rift zones. So rift zones are areas where the volcano is rifting or splitting apart. So again, you can have eruptions at the summit caldera, as well as at the rift zones. The rocks in a rift zone have many cracks and are relatively weak, and thus it's easiest for magma to make its way to the surface through these rift zones. Once at the surface, the lava flows downhill, following local topography. Like water, lava seeks the path of least resistance. Areas downhill of rift zones are more likely to be covered by future lava flows than areas on extinct volcanoes. So here you can see across the rift zone the paths in which the lava has followed. And rift zones here shown in red at Hualalai, Mauna Loa, and Kilauea. They extend well offshore. So the linear area that is being rifted or pulled apart remains active through most of the volcano's building stages. Volcanic rift zones provide the easiest pathways for magma to travel underground from the summit storage region, with successive eruptions from the rift zones building up the volcano's flanks. Again, eruptions that build shield volcanoes are not confined to the summit of the mountain, but occur along fissures extending across the summit and far down the flanks. So the main vent of the 1942 eruption of Mauna Loa was 18 kilometers from the summit, and the 1955 eruption of Kilauea took place more than 32 kilometers from the summit. The cracks that provide the easiest passageway for the rising magma are not isolated, but parts of extensive zones of fissures known as rift zones. Okay, so this concludes Module 2A. Please review this lecture or take a look at the PowerPoint slides to review the material before you attempt Quiz 2A. So again, for Quiz 2A, under the Test and Quizzes tab, you will only be given one chance to take the quiz and it'll be timed. So make sure you are prepared before you attempt the quiz.